All right. So here we're finishing chapter 2, which means we have a test coming next week. We'll do a little review, I think Monday, and the test, or Tuesday for you guys. The test will be Wednesday or Thursday. I'll tell you for sure Tuesday. See how the reviewing goes and where we're at. But test next week. And what they're trying to do here in the very end of this chapter is get us ready for proving geometric theorems in the next 3 chapters. So a theorem is a conjecture or statement that you prove true. Like, for example, the vertical angles theorem. It says, vertical angles theorem says, and we've seen this before, if 2 angles are vertical, like 2 and 4, or 1 and 3, then they are congruent. Which part of this conditional statement is the hypothesis? You guys tell me, which part is the hypothesis here? Yep, if 2 angles are vertical. If 2 angles are vertical, that's the hypothesis. You could do an arrow there. And then the conclusion would be they are congruent. Yeah, I mean, that's how you would describe what the if and then part. I guess you could say the if part is the hypothesis and the then part is the conclusion. But they are congruent. So this is a theorem that's written as a conditional, and the hypothesis is the if part, which we call the given part of the proof, and the conclusion is what you're trying to prove. So with these geometric theorems that we're going to be working with, the given will be the if part, the what you're trying to prove will be the then part, and you've got to fill in between. Okay? So this is an example one. We already proved this one, actually. And the way we proved it was we basically said, these 2 add up to 180, these 2 add up to 180, set them equal to each other, what do they have in common? What do these 2 and these 2 have in common? Yeah, 3. So you pull out 3, and you end up with 2 equals 4. That's the general proof. We've looked at that before. All right. So proof of the vertical angles theorem. Let's go ahead and do this in a more formal fashion than we did when we did this the first time. So it's given that 1 and 3 are vertical angles. Do you guys have that little grid there? So in the number 1 here, we call these statements. And over here we have reasons. And by the way, when it comes to proofs, you can write them like, when I did proofs in my courses as a math major, a lot of them were just paragraphs. I'd write a little narrative, a little paragraph, several sentences. That's totally fine to write it in sentence form if that's better to you. A lot of students, I think, like the shorthand and stuff and the logical thought process with these statement reasoning proofs, but you don't have to do it this way. 1 and 3 are vertical angles. We write that down here. Angle 1 and angle 3 are vertical. And that's given. So let's see, looking at the different things here, eventually we're going to get to the place where we're using the transitive property of equality. That's when we say that, let's draw a picture here again to go back and look at how it was labeled. So 1 and 3 are these 2 right here. 1 and 3 of those 2, and then 2 and 4 of those. So let's go ahead and redraw that picture. I think that'll be helpful. So 1, 3, and then I think it was 2 and 4. So there we go. There's our picture again. So we're going to make a couple different statements here, and they're going to have the same reason. Yes, that's the idea. We're going to say that, what do we have on there? We're going to prove 1 and 3 are vertical. Okay. So we could say 1 and 2 are supplementary, and then 2 and 3 are supplementary. Okay. or add up to 180. So we might do it this way. Angle, yeah, we're going to actually write it like this, though, just based on, that's the problem with filling in the blanks. If we don't have to fill in the blanks, we can actually choose our own adventure and have it look a little different than what they're determining here. Yeah, so the whole right side is filled in for you. Yeah.
2, it's angles that form a linear pair are supplementary.
Okay.
And then for 3, the
Sum of measures. Okay. Okay, so that means they put two things in one. So what they did is, for number 2, they just stated that they're supplementary, and then in number 3, they stated that their sum is equal to 180. That's based on the fact that it says the sum of the measures of the supplementary equals 180. And then they're going to set them equal to each other here, and then they're going to subtract out the thing that's common, okay, which will be angle 2 in this case. And then the last step on there, what does your last reason say?
Those are the same measure.
Okay. So that's just transitioning from the measures being equal to them being congruent. Okay. So the congruent symbol looks like this, and we're going to just transition to that. So you have to kind of write small in the statements. You ready? It'll be like this. Angle 1 and 2 are supplementary. Or what's the region now? Angles that form a linear pair are supplementary. Yeah. So 1 and 2 are supplementary, and then you'll have to write also that angle 2 and 3 are supplementary. And the reason it says is that angles that form a linear pair are always supplementary. So angles, and yours is already filled in, that form a linear pair are supplementary. And then in the next one, we're going to say measure of angle 1 plus measure of angle 2 equals 180 degrees. And measure of angle 2 plus measure of angle 3 equals 180 degrees. And that's just by definition of supplementary. The definition of supplementary, the measures of supplementary angles is always 180. Measure of supplementary angles equals 180 degrees. And then, what you guys had mentioned earlier, we're going to go ahead and set these two equal to each other. So it looks like this. Measure of angle 1 plus measure of angle 2 has to equal measure of angle 2 plus measure of angle 3. And that's by the transitive property. If they each equal 180 degrees, then they have to equal each other. So measure of angle 1 plus measure of angle 2 has to equal measure of angle 2 plus measure of angle 3. And then finally, this is doing the algebra that we did kind of for homework last night. What can you subtract off from each side? Yeah, measure of angle 2. So you end up with measure of angle 1 equals measure of angle 3. That's by the subtraction property of equality. And then finally, this final step is just saying that angle 1 is congruent to angle 3. If the measures are equal, angles with same measures, then their sizes are the same, or they are congruent. So angles, yeah, angles with the same measure are congruent. So angles with the same measure are congruent. And I'm not going to be too particular on this. I just want to see that you have a general understanding of this proof. If you went straight to angle 1 is congruent to angle 3 and didn't have this transition in 5, 6, I'd be okay with that. That would be okay. What I need to see is that you see that transition from taking the two sets of linear pairs, setting them equal to each other, and subtracting out what they have in common. So there's some flexibility in here, okay, in terms of doing these. So don't approach it thinking that you have to get it just the way I'm thinking it should be. There's some flexibility here. All right. It says now we're going to use the theorem. So that's kind of the format this will take. Is they'll ask you to prove some theorems, and then after you prove them, they'll let you use them. Truth of the story is these were proven like 2,000 years ago. So it was the Greek mathematicians like Pythagoras and his some buddies like Archimedes, Thales, other guys that we have Euclid and his elements going on. But we have Greek mathematicians that put together this this geometry course that we study. So they've been proven. You're just kind of walking in the footsteps and proving them again here. Using the vertical angles theorem here, can we set up an equation and solve? What do you think? What do we know about these two angles? They're equal to, they're in the same position as the ones you just proved, congruent, right? So we'd set it up as 2x plus 21 equals 4x. And then you're going to solve. So kind of that same form we're seeing over and over again here. So 21 equals 2x. Don't panic if you get a decimal fraction. Divide by 2, x equals 10.5. That's okay. Especially since it's 2 times x and 4 times x. It won't matter. It's always a good idea here, too. There's a suggestion here in terms of writing 2-column proofs, or writing any proofs, is to plan it out ahead of time. Let's go ahead and, well, I guess we're done with this. X equals 10.5. What they'll oftentimes ask us to do is plug the 10.5 in and get the angles. They didn't in this one, so we're just using the vertical angles theorem to set them equal, solving for x. And I think we could write this in paragraph form, taking what we kind of already planned it out. We just did it in 2-column form. But what might this look like in paragraph form if we write this out? Let's see if we can do that. I'll try to give you an example of that. So we started with, if we go back over here, this is basically our plan, right? So given that, it's funny, proof of 1 and 3 over, let's prove that angle 1 is congruent. It's an interesting way to start. Okay. It's describing that they're vertical. Okay. So using the same picture, we just would take this and write it in narrative form. So we would say something along the lines of, given that 1 and 3 are vertical, we can draw the following picture where we have 2 in there, and state that 1 and 2 are supplementary as well as 2 and 3. And then go to the next step, say that if they're supplementary, they have to add up to 180. Set them equal to each other, subtract out angle 2, and you got it. So there's our plan. We almost need the picture here again, so it goes like this. There's 1 and 3, 2 and 4. So so we might start with the fact that angle 1 and angle 2 as well as, this thing's being sensitive today, angle 2 and angle 3 are supplementary because they form linear pairs. just put a period there. That's the first statement. 1 and 2 as well as 2 and 3 are supplementary because they form linear pairs. And then we might say something along the lines of, therefore, measure of angle 1 plus measure of angle 2. Or you might use the word so. Therefore, measure of angle 1 plus measure of angle 2 equals 180, and measure of angle 2 plus measure of angle 3 equals 180. And then we might use another word, a different word to present the next one. So we can set say measure of angle 1 plus measure of angle 2 equals measure of angle 2 plus measure of angle 3 by the transitive property. This thing will give me all kinds of grief. It's want me to press super hard here. So we can say that those two expressions are equal by the transitive property, and then we might be able to handle this in maybe one more sentence to finish it off. So if those two are equal, if we subtract out measure of angle 2, then we've got that measure of angle 3 is equal to measure of angle 1, and we're set. So if we subtract out measure of angle 2, we see that measure of angle 1 is equal to measure of angle 3, so angle 1 is congruent to angle angle 3. And so, you know, I'm not showing each and every detail, but more of a narrative. That's a paragraph proof, totally fine. As a matter of fact, if you become a math major and go and take higher level math courses where you're doing proofs, that's what you'll do. You'll write it out in a narrative with pictures. Okay? Most likely what you'll do, explaining how you know it's true. And it's like writing an essay. It is. It's kind of a short one. Math, we get to use symbols and shorthand. So it's a little better. So one thing I appreciate about math is you can use symbols and abbreviations and stuff. I didn't have to worry about my grammar so much. But I just need to be able to understand that you know why it's true. And pictures are awesome. You use pictures and arrows and everything else. Totally fine. Okay, but that's a paragraph proof. All right?